Using the same example, now we're going to talk about finding excluded values. So, excluded value is when you're trying to find a value of the variable that makes the denominator equal to 0. So, if we were to look at the original example from here and then factor the denominator. So, if you are asked to find excluded values, you mainly focus on the denominator. Don't worry about the numerator, just the denominator. After factoring, this is your pair of factors. The n plus 3 where I crossed out, and the 5n minus 6. So, basically, you're saying what you're trying to do is finding the value of n that makes the denominator equal to 0. So, in order to do that, what we do is I'm going to set both factors equal to 0. So, my first one is n plus 3. So, n plus 3 equal to 0. And then your second factor, 5n minus 6 equal to 0. Now this one's pretty straightforward, so minus 3 on both sides. So n equals negative 3. Now, here, I'm going to add 6 on both sides. So 5n equals positive 6. And then I'm going to divide both sides by 5. So this one will be n equal 6 over 5. Now, be mindful. I asked to find excluded values. So, if I'm looking for excluded values, I need to say that I'm looking for excluded values. So, let me write excluded value. Such that n would equal to 3 and 6 over 5. So that would be my value for excluded values. So I'm going to underline that this is my answer for excluded value. Now, sometimes the question might be phrased differently. Sometimes it might ask you, find what values that the denominator cannot have or cannot equal to. So, if the question was not phrased using excluded values, but asked you what values can the denominator not be. So, if you read a question like that, or heard the question phrased like that, saying again, what values can the denominator cannot equal to? Meaning after you factor, basically, to say n plus 3 cannot equal to 0, therefore n cannot equal to negative 3. 5n minus 6 cannot equal to 0, so therefore 5n or n cannot equal to 6 over 5. Now you only write that, the not equal symbol, when the question is phrased, what values can the denominator not equal to? So, it's the same process. You factor, and then you find the value of n's. For excluded value, you can say n equals 3, 6 over 5. But if the question is, what values can the denominator not equal to? Again, you still have to simplify by factoring. After you factor, to simply write each factor as not equal to 0, not equal to 0. And then what answer you get? N equals, and not equal to negative 3. And not equal to 6 over 5. So, be aware of that. Make sure to read the question carefully, and then set up your work according to that question. Now, using the previous second example, say that I was asked to find the excluded values, or basically values that the denominator cannot equal to. So let's talk about excluded values. So, after you factor the denominator, which was r plus 1 and 2r plus 7, now, again, if I was looking for excluded value, what I'm going to do is set my factors, r plus 1 equal to 0, solve for r, so this one, r equals to negative 1. Alright, now the other factor, 2r plus 7 equal to 0. So minus 7 on both sides. Then I divide both sides by 2. So r equals to negative 7 over 2. So again, that's r equals negative 7 over 2. Excuse my handwriting. Now, I was asked to find the excluded value. So let me write excluded values up here. Where r is equal to negative 1 and negative 7 over 2. So that would be my answers for excluded values. Let me underline in red. Excluded values. Now, again, if you were asked to find what values that the denominator cannot equal to, if that was your question, so basically just say r plus 1 not equal to 0, therefore r cannot equal to negative 1. 2r plus 7 cannot equal to 0, so therefore r cannot equal to negative 7 over 2. Again, that's for if the question was phrased or written, what values can the denominator cannot equal to? So, that is for the answer for excluded value for the second example. Now, using the same third example, and you were asked to find the excluded values, so again, we're just going to focus on just the denominator. Don't worry about the numerator, even though in this example we factored the trinomial top and bottom. So for excluded value, we just mainly focus on the denominator, and then we're going to set each factor, even though that we cross out n minus 10, we still have to include that. So we're going to set each factor equal to 0. So the first one, 3n plus 2 equal to 0. So I'm going to subtract 2 on both sides. So 3n equals to negative 2. Divide by 3. So then this one would be n equal to negative 2/3. Then I'm going to set the second factor, n minus 10 equal to 0. Solve for it. So I get n equals positive 10. Now, I'm going to write excluded values right here. Where n is equal to negative 2 over 3 and positive 10. So that would be our answers for excluded values. Now, to review, if the question was phrased, find the values of n that the denominator cannot equal to 0. So simply, changing the work, 3n plus 2 not equal to 0. Therefore, n does not equal to negative 2 over 3. Changing this, n minus 10 not equal to 0. So therefore, n does not equal to 10. Again, you do that if the question was phrased, find the values of n where the denominator does not equal to 0.